So let's get into the presentation of SurePatient Smart Search. We must acknowledge that many patient records look the same. Family members, people with the same names, twins, common names. Theoretically, at least, every patient should have one unique record in the MPI. But how confident can we be that the patient record we found is actually the correct one? How can we be sure that this record does not belong to another patient? Can we really be sure that we found all of the patient's records? With such a high duplicate average count in industry, 8% by AHIMA measurements, we have a 1 out of 12.5 chance of getting an incomplete record. And this is because our EHR searches are problematic. That is to say, the EHRs assume perfect data because it's text-based search. And that's a huge limitation and the reason for all of our duplicates. Because if the data is not exact, then we don't find the patient record. It's really quite that simple. And EHR search, frankly, just misses the mark when data is not perfect. So let's understand a little bit about the data errors that we're talking about. They accumulate day by day. They're accidental. Fortunately, no single error is usually catastrophic. Every misspelling, every address error, every piece of missing information is going to contribute to those duplicate error problems, or worse, overlays. Really what it comes down to is data errors equals search failures. And search failures are what cause duplicate records, and sometimes overlays. Let's acknowledge first that our data is full of errors. We can all agree with that. Then let's think about every time we use a browser and search with Google, Yahoo, Bing. They just work. So if we think about other industries that do search well, industries that we use the tools every single day, at work and at home, we should ask ourselves, what should we use to search medical data? And the answer, of course, is technology that leverages the techniques that internet search technology uses in its application. And that brings us to the topic of modern search. And let's define modern search. It must work with errors in the MPI because we know we have many errors already, as we discussed. The search must be accurate. We can no longer afford to keep on saying we can't find the patient, so therefore we're going to create a new record. The search must also be fast. That's critical. In the high-speed, high-pressure registration offices for the emergency department, the admissions office, or in scheduling offices where the phones are always ringing, our search has to find the patients as quickly as possible. The search must also be user-friendly. Think about it. We get on the internet and use internet search easily and without training. The search also has to be smart. Just like Google, when you search, say, for movies, it knows your location. It understands the context in which you're searching. And it's the same thing with patient search. If I'm searching for a patient record, say Jim Hoover, my name, it should also understand there's probably a record under James Hoover, as well as James Huber, where someone misspelled my name because I didn't pronounce it as clearly as I could. We've already talked about it must work with errors in the MPI, and that's the fundamental driving principle for modern search in healthcare. Our data has errors by definition, and our search needs to work with errors by definition. And that leads us to our final requirement for modern search, that it has to be fault tolerant. In other words, search can still find patients even when there are a lot of errors in what we type in their name in the search fields or in what is in the database, the MPI itself. Modern search must tolerate errors in every location and still give us the results. And this fault tolerance is important because many records have multiple errors. So let me give you an example of what we're going to demonstrate today. We're going to try to find a record of a patient with the name Janet Montague. So for Miss Montague, the first thing we're going to do is reverse her first and last name. Then we're going to introduce errors in the name, the first name Benit instead of Janet, the last name ultimately Nantaglu instead of Nantague, and we will find the record until we produce a failure with these subsequent edits in the name. We will introduce the address, and then we will perturb the address, removing digits, misspelling the street name, ultimately till we break the search again. Then we might introduce a telephone number or social security number, and do the same. Change the data character by character until we see the point of failure. The important thing to consider is that most search systems, and probably all EHR systems, cannot find a patient with 10, 12, 15, 20 errors in the search data. Yet modern search, smart search, fault-tolerant search does and can. So let's get into that demo and I'll show you what we're talking about. So just like in the presentation, I'm going to put in the last name Montague and the first name Janet. We find the patient, and up pops the medical record, and the test patient is a picture of my mom. Shh, don't tell her I'm using her photos. We can check the score and see that it was perfect match for what we typed. But what if we reverse the first and last name? We will find the same patient, except the score is a little bit lower. We deducted part of it because the names were in the wrong location. Now we'll start to perturb the name. We'll search for Janet first, and we'll make some changes to the last name in a moment. Lower score 0.863, rather. But you see, we are still finding the same patient, even with a grossly misspelled first name in the wrong location. And the system shows we have 2 out of 3 characters that are incorrect, and 1 field that's reversed. Now let's mess with the last name, Montague. Let's make it Mantiglu. Add 3 more errors to the name. Now we've got 3 errors in the last name, 3 errors in the first name, and the name's reversed for a total of 7 errors, and we still find the patient. That's incredible. Now let's make it Benit. Finally, we made the system fail. Finally. So what do? We add more information. This is the key part about overlays. The more information we type into the record, the more precisely we're going to dial into the correct patient. With this new approach to search, the best practice is to type as much information into the search rather than less. Now let's type in the street address. 2406 7th Avenue, or Ave, and we find the same patient. Let's mess with the address a little bit, and maybe misspell 7th. Actually, not misspell. Let me correct myself to give an abbreviation. It's part of the smart search, using synonyms for things that might be spelled different ways. Let's change the number, remove a 0. Now we change the address. We maybe Avenue instead of Avenue, so we've got even more errors. We'll finally misspell 7th now. We'll make it 7th, I can't even pronounce it. We'll make it 7th now, and ultimately when we remove the N, we make it fail. I don't want to go through every field because it gets monotonous, but let's just throw in the social security number. Let's get it correct to start. We have so many errors, 8 in the name. We have errors in the address. 1, 2, 3, 4, 5, 6, at least 6 errors in the address. Now we're making errors in the social security number, and eventually we're going to cause it to fail again. But this is the power of modern search, fault tolerant and smart. Now with 1, 2, 3, 4 errors in the social security number, it finally failed. Alright, I'm going to type in the home phone number just for grins. So you can see, just adding a little bit more patterns that match, we can still detect the right record. And if I make some mistakes in the phone number, make a mistake in the front, maybe my finger slipped, I typed an 8 instead of a 9, you can see the score is still pretty high, 0.6. Change one of the other area code numbers or local code numbers, and then change the last digit. Finally, it should fail. Mercifully, no, it hasn't failed yet. Let's give it one more. One more error. Okay, it finally failed. You get the idea. Even with 21 errors, we still find the patient. It's not perfect, but it's pretty good. So how was that demo? Pretty cool? You're probably wondering, how in the world does that work? I'm sure. So let's get into it. Modern Search profiles the medical records. It converts the text in the record to, let's call, a mathematical form. Just for the sake of discussion, I'm going to call it a histogram. We can visualize how Modern Search works because it's really based on pattern matching. When the patterns don't match, then the records are not the same. And when the patterns do match, close enough anyway, we consider the record similar. And this is the same for search as it is for record matching. When the records are close, we have a success. They're not exact, they're just close enough, the patterns match. This is the essence of fault tolerance. That enables us to find Nantaglue-Bennett at 246 Sivith Avenue in New York, to find the record Janet Montague at 2406 7th Avenue in New York. Let's count the number of errors in this particular match. First and last name reversed, that's 1. Then 1, 2, 3, 4, 5, 6, 7, 8 errors in the name. That's 9 errors. Then 1, 2, 3, 4, 5, at least 5 errors in the street address. Then 3 errors in the telephone. Then 3 errors in the social. Then 4 errors in the city. That's about 23 errors, plus or minus a few, because I'm getting old and my math might be wrong on the fly. But about 23 errors, and yet we still found the patient record. That's outstanding. That's how Modern Search works. And today's EHR search, even the newest EHRs, simply cannot do this. But they should. What this boils down to, what it really means is less duplicate patient records, less overlay records, safer patients, less expense to clean EHR MPIs, less lawsuits due to malpractice. It also means on the revenue side of the house, less denials because we have the data correct before we send in the claim. So thanks very much for watching the video. Hopefully it was fun, informative, and if you're interested, please email me or on LinkedIn to get a demo. Happy to show you how this software works in both search, patient matching, and error prevention. jhoover@medarcus.com or follow us on social media @medarcus, LinkedIn, Facebook, Instagram, Twitter. Have a great day. Thank you.